Let us go through the question from the topic rotational kinematics. In circular motion, it is question 29, chapter 11, Eric Mazar textbook. You attach one end of a string of length L to a small ball of inertia M, as shown in the diagram over there. You attach the string's other end to a pivot, as shown over there, that allows free revolution. You hold the ball out to the side where the string tilts along a horizontal line, as in figure P 11.29. So the question says, if you release the ball from rest, what is the tension T in the string as a function of the angle theta swept through? Okay. So before we proceed to analyze the question, maybe let's analyze our diagram. So the string is attached to the ball here, and then it is also tied to a pivot over there. So the ball is gonna be rotating all the way, it comes down and up until to the other end, and then it goes back to the other end. So this is how the ball is gonna be rotating about the pivot. Okay. So yeah, let's analyze the question. It is saying, if you release the ball from rest from that point, what is the tension T in the string as a function of the angle theta swept through? Okay. So one thing to know is that tension is a force. Okay. Tension is a force. So in order to find the tension, it is going to be given by the summation of all the forces that are acting on the ball. Okay, so in this case, these force will be given by mass multiplied by the rotational acceleration. Okay, so the steps in solving this question, we actually at the end we're gonna use the forces to find our tension, but we're gonna have to find rotational acceleration rotational acceleration that we want to use, and it is given by the formula v squared over r. Right. So the next thing to find, you can see here in our formula for rotational acceleration we have velocity. We're going to have to find velocity before we can find rotational acceleration. And then in order to find velocity, we have to use conservation of mechanical energy. We have to use conservation of mechanical energy to find our velocity. Okay, so we know that for mechanical energy, summation of potential energy and kinetic energy equals 0. So we want to find our potential energy that is given by the formula mass gravity times height, which equals kinetic energy, which is given by half mass v squared. So this h over here, we have to find it from our diagram because we know that h is actually a vertical distance from the ground. A vertical distance from the ground. So we have to draw a vertical line in our diagram and then find the relationship between the vertical distance and our quantities that are already provided. Okay, so if I say sine theta equals sine theta over here, this is h. Sine theta is equals to h over our hypotenuse, which is L. Okay, so to make this clear, let me just draw a line like this. Okay, so this is the radius, which is still length L. Okay, this is still length L because this is the radius, right? So this is h. So sine of theta is equals to opposite over the adjacent, which is h over L, which is h over L. So our L is going to be given by h sine of theta. So this is going to be our expression for L that we're going to have to use in our formula. So the mass multiplied by G, and then multiplied by the expression for H that we got is, this was a mistake, it's actually the other way around, which is H is equals to L sine theta. Okay, so expression for H is L sine theta. Okay, which equals half mass. This could remember our goal here is to find velocity. Okay, so we write the expression for velocity. So the m will cancel over the, so we reduce this one and get v squared equals to 2g L sine theta. Okay, so this is our expression for velocity. So now we have our rotational acceleration. So the formula is v squared over r, in which r equals the length. In this case, radius is expressed by letter L from our diagram. So we're gonna come and say our v is 2g L sine theta divided by L, as I've explained today that r equals L. Okay, r equals L. So the L they will cancel, and then we'll remain with our acceleration is 2g sine of theta. Okay, so now we have to move on towards finding our solution. So I explained today that tension is given by the summation of the forces, which equals mass times acceleration. So our force is going to be mass. So we have to substitute rotational acceleration there, that is given by 2g sine of theta. So this is going to be the answer for our tension.